Hello, this is my English speaking practice, and I'm talking about my learning of Linux. And yeah, I have decided to change the content I broadcast. Yeah, uh, I have enough about my personal development, and today I I played it with my friends, and it was so fun, and it worked. It worked well. Yeah. So it's good time to switch the content, and I'd like to learn Linux, especially for performance. So from today, I'm I start to learn about Linux performance, and also I this is good for my work because I worked in the Linux team. It's a kind of a Linux team, so I needed to study Linux performance. Yeah, and I found this blog, and this is so good. This blog, this homepage is by Mr. Mr. Brendan Gregg. Yeah, and he is so special, and he wrote he have published famous books like this, and systems performance. This is translated into Japanese, and I have this one. Yeah, yeah. So this blog is so reliable, and there is a lot of things to study. So I'm going to start to learn from this. But I haven't decided how should I study this. So today I'm gonna take a look around this page. Yeah. And also just reading English is also good for my English training. So if I'm stuck in speaking English, I will read these sentences. This is good to broadcast this is the just reading sentences is good, so that I don't want to be stuck in speaking English. Yeah. So let's take a look at this page. Links to various Linux performance material I've created, including the tool maps on right. This and on right. Okay. These use a large font size to suit side text. You can also print them out for your office wall. They show Linux observability tools, Linux static performance analytics tool, Linux benchmarking tools, Linux tuning tools, and Linux SAR. Check the year on the image bottom right to see how recent it is. Bottom right. This. Okay. Oh, I see. I thought these are same, but this graph is same, but the commands around this is not same. So this is about observability tools, and this is performance tools. This is about benchmark tools. This is about tuning tools. Performance observability. This is about SAR command. This is about perf tool. Yeah. Looks nice. This is BPF tracing tool. Yeah, I'm interested in BPF. Yeah. Okay. What is this? Okay, this is about tools developed by BPF mechanism, BPF tools. Okay, got it. And there is also a high-res diagram combining observability, static performance tuning, and perf tools, BCC. But it is not as complete as the other diagrams. For even more diagrams, see my slide deck below. Okay. This is the tools developed by Mr. Greg, I think. BPF is but BPF trace. I don't know, but yeah. Yeah, I think these tools are developed by him, and documentation is like this. There are a lot of documentation. Yeah. And this is the talks. And I guess he works at Netflix. And also he is familiar with eBPF. Yeah. Okay. How should I start? This is the blog. Oh, I see. But there is a blogs since 2014, but not so much. Not so much. Okay. How to start? Where should I start? This is. I'm curious. Okay, I will read it. Performance tuning Linux instances on EC2. This includes instance selection, EC2 features, Linux kernel tuning, and the use of observability. This is the most comprehensive tuning talk I've given and summarizes the different ways we tune at the instance level. It should be useful for anyone running Linux in the cloud, not just in EC2. How long this blog is? Oh, not long. Okay. The slides are but 81 pages of slides, and this is a video. Okay. Let me read it first. I often share my work on performance observability, but not tuning. Observability is where the bigger wins are, as you can discover and then eliminate unnecessary work. It can also help show that tuning is required, but I've also been meaning to share same examples of tuning and had my chance at AWS re:Invent. In the third section of the talk, I included the tunable we are using on Ubuntu Trusty. Tunables. To show examples of what is impossible. These are tunables. Okay, tunable configurations like that values, tunable values. Okay, and I've included them below for easy following. Please watch the video for context. Okay. Schedule tool. Swappiness. Okay. Huge pages. Okay. File systems, storage I/O, networking, hypervisor. There are things I can understand and also things I have no idea on. How about a sentence? There are Hmm. There are things I understand and things I don't. Some things I understand and others don't. I don't. Okay. Yeah. Mm, for example, this is about configuration of swap area for virtual memories. Yeah. Settings the clock source came from a performance regression we found. Clock source, what is this? When moving to Ubuntu Trusty, which can be fixed by switching clock source to TCS. Best case example so far, CPU usage reduced by 30% and average app latency reduced by 43%. Be aware of clock drift, as in the distant past TCS has been unreliable. I have no idea about TCS and clock source. In the talk, I described these tunables as our medicine cabinet and to consider these best before 2015. Tuning is a process, not a product. Copy and pasting these tunables is a little like taking someone else's medications. Doing so years later is like taking someone else's expired medicine. Okay, so it's he says copy pasting is not good as a solution of tuning. Okay, copy and pasting this tunable is a little like taking someone else's medicine. Doing so years later is like, but I don't know the exact translation, so let me okay. So this is the additional meaning. This is not good. In addition, doing so years later is like taking someone else's expired medication. Okay, I see. And as an update, okay. Okay, so I should watch. Look, I should watch the slides. Yeah, he is from Netflix. Okay. Performance engineering team, and they use this Amazon EC2. Okay. Instance selection. Okay, this is best before 2015. Take only if described by a performance engineer. Okay, I see. Instance selection. Yeah. current generation instance families is like this. Yeah, currently there are a lot of instance families. But basically this is same storage optimized and memory optimized, compute optimized, general purpose. Yeah. And instance sizes. Yeah. This is so small. Okay. Instance selection flowchart. Okay. Need large disk capacity. Yeah. Large disk capacity. For example, what do I say? From the very beginning. Disk I/O bound, cache, can cache. Select memory to cache works. Working set. Where are the destination? Okay. And trade-off, you can choose from these three families. Okay. So basically we are supposed to use these three ones, but if you need large disk capacity, select I2, or if the workload is disk I/O bound and it cannot be cached, use I2. So so need to use the storage optimized. Okay. I'm not sure. I feel like I cannot run a lot from this slide. This is just a slide, so I need more explanation. So I should read the document or something like that. And I prefer the recent documents or more fundamental theories. How about this? Hmm. Hmm. I need more explanation. Hmm. This is the yeah. This is a book. So yeah, I have this book. But I cannot read it on this broadcast. Yeah, there is due to the copyrights. So this is not good. This is also book. Let us see the eBPF. I'm curious about this. Okay, let me take a look at. I've taken one small step with eBPF, but it heralds one giant leap for Linux tracing. Oh. Okay. Okay, I see. And this is a byte-hist tracing block device IO interval 5 sec. Okay. The output from my byte-hist tool shows that most disk IO was between 4 and 7 kilobytes in size. I see. And during the 5 seconds of tracing, okay, there was also a smaller amount of between 32 and 63 kilobytes. Okay. Okay, this is about one, yeah, IO size and IO count during the 5 seconds. Okay. This uses a custom in-kernel histogram implemented via an eBPF map. Maps can provide many things, including the covered it. I don't like search on Yahoo. How do I fix it? Settings, default engine. Oh, why this is changed? Okay.
Coveted.
Coveted. Coveted latency histogram are staple of Sans detracing utility, and other detrace maps are efficient. eBPF maps may be even more so as they are JIT compiled. In this example, the maps allows just the histogram data, the count column, to be passed from kernel to user level. It's populated using a custom eBPF program and use dynamic tracing of kernel functions. This is my first post about eBPF extended Berkeley packet filter. And I will summarize how we got here, why eBPF and maps are important, and where we are likely going to next. I heard maps for the first time at the context of eBPF. So just a data structure. In this example, the map allows just the histogram data count column to be passed from kernel to user level. It's populated is I'm not sure, but I guess this is a key and this is the value, and this is a map. Okay, go to next. Why we need eBPF? Linux tracing has greatly improved in the past 10 years. ftrace and perf events are now part of the Linux kernel, which lets you analyze Linux performance in detail and solve difficult processor, kernel, and application level issues. Their capabilities have let me port some of my old dtrace tools to Linux. I've released these as a perf tools collection, which I spoke about at LISA 14 and wrote about in LWN.net. But I've sometimes run into limitations such as wanting low overhead latency histograms. That capability and much more is made possibly by eBPF, which began life by extending packet filtering capabilities. eBPF is now being integrated into the Linux kernel in stages. It's as if Linux is gaining superpowers one at once. This blog is written in 2015. Okay, I see. eBPF is already integrated into Linux kernel, I think. And here is how kernel developer Ingo Molnar described the eBPF in an April 2015 LKML post. One of the most interesting features in this cycle is the ability to attach eBPF programs, user-defined sandboxed bytecode executed by the kernel, to kproobs. This allows user-defined instrumentation on a Linux kernel image that can never crash, hang, or interfere with the kernel negatively. Okay, this addition to Linux 4.1 is a giant leap forward, as it allows new efficient kernel instrumentation to be created. eBPF will eventually attach to more than just kproobs as well. Okay, I see. I'm excited about eBPF. I've tested it a number of times during the past year and have discussed it with its developer Alexey Starovoytov. I also summarized it at the Tracing Summit and introduced the unofficial eBPF mascot, the ponycorn on the right. Okay, eBPF has many features. A differentiator from other tracing tools is its map. So this is the important features in the eBPF. eBPF maps are populated in kernel by your custom eBPF program and can be read from user level code asynchronously. Maps have many uses, including this is not just a data structure. Okay, this including histograms, log, linear, or entirely custom. Okay, summary statistics, counts, average, min-max, frequency counts, event count by PID, latency, storing and retrieving timestamps by event from measuring latency. The histogram that my whitehist program print is stored as an array. More complex data can be stored in a key value hash. Example, byte size 5.2. This is interval 5 sec. This is storing a histogram by PID. It shows that the checksum command was using 128 to 255 kilobyte disk I/O, This is the PID and this is the command checksum CKsum, and this is about the disk I/O and the 128 to 255 size of I/O is the most happens. 200 to 155 size of I/O most likely happens, and distribution is like this. And this is about dd command. This is okay, I see. Show me the code. I have previously described eBPF's ease of use of brutal, and by comparison with other tracers, it still is. My original dtrace version of byte size is about a dozen lines of code, but it couldn't easily be a one-liner. My eBPF version written in C is currently over 200 lines of code. The good news is that it's going to get easier, which I'll discuss in a moment, but if you're curious about what the code currently looks like, the source for both my program is on GitHub, byte hist and byte size. This is byte size. This is byte hist. Okay. These are based on Alexei's eBPF samples, which are worth checking out. Below are some snippets from byte hist. The following declares a map of type array. eBPF map type array. Let me see. This is the okay, I see. So the map means like this kind of data, I think. eBPF map. And specify the size of the key value and number of elements. Key value, number of elements. I see. So hist map. This stores a histogram. Okay. The following populates the map. Yes, the kproof interface is unstable. This should use trace points instead when they are supported by eBPF. The following populates a map. Yes, the kproof interface is unstable. This should use trace points instead when they are supported with kproof is not a stable ABI. Kernel functions can be removed, renamed, or completely changed semantics. Okay. Number of arguments and their positions can change, etc. In such case, this BPF plus kproof example will no longer be meaningful. Is this a bad example? Kproof interface is unstable, and this fetches the map data from user. I didn't get it. Print log to hist. The byte size program uses a hash instead of array. Where the key is a C struct containing both the process credentials and kilobyte index, and the value was the count. I understand 20%. Kproof. Oh, I see. I understand. Kproof interface is unstable. This should use trace points instead. Okay. I understand, but this example uses the Kproof. Okay. Future. In the natural course of writing these programs, Alexei and I have created some common functions and program templates that can be reused. Example to print histograms, calculate log to clear maps, etc. This means that programming eBPFC will be down here from here. However, down here. Warson, okay. Where it is? Oh, okay. Why does this mean that program eBPF will be down here from here? However, its difficulty should not be a major problem for adoption. Yeah. In the natural course of writing these programs, Alexei and I have created some common functions and program templates. Yeah. Why this means down here from here? I don't know. However, its difficulty should not be a major problem for adoption. Yeah, as I found with dtrace, many people just wanted to use my programs, not write them themselves. The same should also be true of eBPF. So long as Alexei, I, and others write and publish useful programs, eBPF should be used successfully. That said, there could be an eBPF front end to provide a higher level language of ease of use. This is something the KTAB developer Joby Zhang Wei has done. This is done. I have seen these spells a lot. Jiang Wei, Joby Jiang Wei has been considering. Developers at Huawei have also been working on BPF subcommand to perf. Another system monitoring project, Shark, already claims eBPF support, although I haven't tried it yet. I'd expect the inclusion of eBPF in the kernel to trigger support in all traces. We should also see new uses, both for observability and functionality, come out of eBPF. By the way, we also know that eBPF is not an illustrative name. Have a better idea? EB Black Pony Flying. Too much eBPF, and the mascot has been suggested. Okay, but I don't know this meaning. Why? This is a positive one? Okay. It requires less efforts than climbing uphill. I understand. But this is worsen as in So there are two opposite meaning. Okay, I see. More examples. Alexei's eBPF samples includes trace x34 showing disk I/O latency as a heat map. This axis is about latency and passage of the time. This is the time. So these disk IOs are low latency, and these are high latency. high latency. And this means the bulk of I/O, it yeah. Mm, mm, mm. Okay. The passage of time is only the y-axis going downwards, and latency is on the x-axis. The color depth shows how many I/O fell into a time and latency range, darker for more. This particular example shows that most I/O took around 9 milliseconds here, but with a wide distribution. I've noted some other features on this image. Yeah. Let me original. Same. Same image. Latency heat maps shows not only the distribution of latency, including multiple modes and outliers, but also changes over time. See my latency heat maps page for an introduction. The TraceX3 program uses one map to store timestamps when this IO is issued, and another map to storing latencies as a histogram, which is read each second from the user level program. Conclusion: eBPF is being integrated into the Linux kernel and allows new observability tools to be created as well as other uses. In particular, it allows the creation of low overhead latency histograms and heat maps for detailed performance analysis. My ByteHist program may be one small step with eBPF, but its use of custom in-kernel maps is a huge leap for index tracing. Let me eBPF map. eBPF. Oh, I see. Here. Okay. Maps provides a way for eBPF programs to communicate with each other, kernel space and with user space. When both kernel and user space access the same maps, they will need a common understanding of key and value structures in memory. This can work if both programs are written in C and they share a header. Otherwise, both the user space language and the kernel space structures must understand the k-value structures byte for byte. Maps come in a variety of types, each of which works in a slightly different way, like different data structures. Okay, defining maps in eBPF program. Before we can start using maps in our eBPF program, we have to define them. Legacy maps. The legacy of defining maps is use the structure BPF map def type from libbpf's ebbf site library or from the Linux U API. These map declarations should resize in the map ELF section. ELF, I have heard this. This is executable and linkable format. Common standard file format for executable files, object code, shared libraries, and core dumps. First published in specification for the application binary interface of the Unix operating system version named System V release, and later in the tool interface standard. It was quickly accepted among different vendors of Unix systems. In 1999, it was chosen as the standard binary files format for Unix and Unix-like systems on x86 processors by the x86 Open Project. By design, the ELF format is flexible, extensive, and cross-platform. For instance, it supports different NDNSs and address size, so it does not exclude any particular CPU or instruction set architecture. This has allowed it to be adopted by many different operating systems on many different hardware platforms. Okay, let's see the file layout. Each ELF file is made up of ELF header followed by the file data. The data can include program header table describing there or more memory segments, section header table describing there or more section headers. Data referred to by entries in the program header table or section header table. This is ELF. This is a format. Simple ARM. And headers. Header section. Header. Okay, this is the code data. Let me see. Here is the assembly. Okay, and the data is how to indicate the data. So hello world is here. I don't know. I understand about this. This is a binary data and executable and linkable format. Yeah, and it's flexible. Yeah. Okay. Where is the where is the page? I here is the page. Okay, so these map declarations should reside in the maps ELF section. The major downside of this method is that the key and value type information is lost, which is why it was replaced by BTF style maps. The new way of defining eBPF maps which utilize BTF type information. See mailing list links for implementation details. These maps should be located in the maps section for loaders to proper equal. Okay. I'm going a different way. I'm going on the different way. What I want to know is about performance. It's not the architecture of eBPF. So let's go back to here. I should decide what topics should I focus on. How should I? I should run the more fundamentals. But how to computer. Yeah. Fundamentals. This page looks. Ooh. about frequencies. And networking, kernel development. Oh, okay. But this is not what I want. This is fundamental, I think. Let me this is too easy. This is too fundamental. Welcome to this lab on file system and disk management in Linux. This lab is designed for beginners who are just starting to explore the world of Linux system administration. We'll guide you through essential commands and concepts related to managing disk space, creating virtual disks, and maintaining file systems. By the end of this lab, you will have hands-on experience with fundamental Linux disk management tools. Viewing disk usage with df disk-free command. I know. You will see output similar to this. Yeah. Don't worry if this looks confusing at first. Let's break it down. First, system disk columns shows the name of disk or partition. Disk or partition. Okay. 1K blocks. This is the total size of file system in 1 kilobyte blocks. Used. This shows how much space is currently in use. Available. This shows how much free space is left. Use percent. This shows the percentage of the file system that is in use. Mounted on. This shows where in the directory tree the file system is mounted. Now let's make this output more human readable. Run. Yeah, H option stands for human readable. You will see output like this. Much better, right? Now the size are in GB, MB, gigabyte and megabyte, which is easier to understand. If you want to check the space on specific file system, you can specify it. This will show information only for dev VDV file system. The df command is incredibly useful for quickly checking how much disk space you have left. If you ever run into issues where your system says it's running out of space, df is often the first command you will use to investigate. Okay. This content is easy for me, but it's a good content to speak English. Yeah, because this is so understandable, easy to understand, so I can focus on the English structure and reading it. Okay. and examining directory sizes with DU. Yeah, our DF gives us an overview of disk usage. Sometimes we need to dig deeper. That's where DU, disk usage, comes in. It helps us understand which directories and files are taking up the most space. Okay, let's start by using DU in its simplest form. You will see a long line of numbers and directory names. Each number represents the size of directory in kilobytes. This can be overwhelming, so let's make it more manageable. Each option, just like with DF, makes the output human readable. You will see size in kilobyte, megabyte, or gigabyte as appropriate. Often we just want to know the total size of the directory for this use. S means summarize, and caret, this is how to say wave line, represents your home directory. These commands will show you the total size of everything in your home directory. To view the size of immediate subdirectories in your home, this shows the size of each subdirectory one level deep. The max steps 1 option limits how far DU will recurse into subdirectory. Let's check the size of item in your home directory. This will show the size of each item directory. Directly. Confusing. This shows the size of each item directory under your home directory.
Directly. Directory.
It's same. This is same for me. Directory. Here is a powerful command. Here is a powerful command to find the largest items in your home directory. This command is a great example of how you can combine simple Linux commands to perform more complex operations. Okay, I see. DD command is not familiar to me. Creating and managing a virtual disk. Before we dive in, let's understand what a virtual disk is. A virtual disk is simply a file that acts as physical disk drive. Think of it like creating a container file that the operating system can treat as if it were a real hard drive. This is similar to how virtual machines use virtual disk files to store their data. Why would we want to do this? Virtual disks are useful for testing disk operations safely without risking real hardware, creating isolated storage spaces, learning about disk management without needing additional physical hardware, creating backup images of the real disks. Important concepts. File system. Think of a file system as a way files and folders are organized on the disk. It's like a filing system in an office. It determines how data is stored and retrieved. Common Linux file systems include ext4, which we will use, XFS, and BTRFS. Mounting is the process of making a file system accessible to the operating system. When you mount a file system, you are telling Linux make the contents of this disk available at this specific directory. It's similar to plugging in a USB drive, the physical connection, then telling the computer where to show its content. Partitions. A partition is a section of a disk that's treated as a separate unit. Think of it like dividing a large hard drive into smaller, independent sections. Reasons for partitioning include separating system files from user files, using different file systems for different purposes, making backup easier, limiting the impact of disk failure. Okay, let's create a work with the virtual disk. First, let's create a 256 megabytes virtual disk using cd command. I haven't used this command. Okay, let's break this command line. It's a utility for copying and converting files. If dev0 means input file is dev0. Input file, a special file that provides endless zeros. OF, output file is virtual.img. NBS sets the block size to 1 megabyte. The current means copy 256 blocks, resulting in a 256 megabyte file. Block size times counts, and this creates an empty file filled with zeros that we'll use as our virtual disk. I see. Let's see. Verify the file size. Let's format this virtual disk with ext4 file system, mkfs ext4 virtual.img. What's happening here? This command creates a new ext4 file system inside our virtual disk file. Set up the basic structure needed to store files and directories. Is similar to formatting a new USB drive before first use. Is the ext4 file system is the default for the ext4 is a default for many Linux distributions because it's reliable and well tested. Now we need to create a mount point. This is the directory where the contents of our virtual disk will appear. We can mount the virtual disk. Okay. all loop option tells Linux to treat our file as if it were a real disk device. This is... I have no idea about this. This is a source and this is a destination. Okay. Okay. Let's see the fdisk. In a real system, before you can create a file system, you often need to create partitions where we can't modify actual disk partitions in this virtual environment. We can explore how to use fdisk to view partition information. I have used zdisk command, which is similar to fdisk command. Fdisk and zdisk are both command line tools for managing disk partitions, but they work with different partitioning schemas. Fdisk is primarily used for the order master boot record partitioning scheme, while zdisk is designed for the newer guide partition table (GPT) scheme. Zdisk is part of GPT fdisk suite, which also includes I see. So zdisk is the newer version. Let's view information about all disk partitions. This will display information about all disk devices and their partitions. You will see details about the disk size, number of sectors, and partition table. Now let's look at the partition information for virtual disk. This will show you the partition table of virtual disk since we created the file system directory on the disk image without partitioning. You might see a message saying that it doesn't contain a valid partition table. In a real system, you would use fdisk interactively to create, delete, or modify partitions. You would use fdisk. Here is a brief overview of how that would work. You start fdisk with sudo fdisk dev sdx. Replace x with the appropriate letter for disk you want to partition. You'd use the command n to create a new partition, and d would delete the partition, t would change a partition system ID, w would write the change and exit. Yeah. Okay. Oh, there are a lot of courses. It's a little bit easy. Okay, today I'm going to finish, but let's think about what should I do in this broadcast series. this video, I have read sentences a lot, but I want to speak in English, and so ideally I want to speak what I'm thinking. And personal development is good for that, because I have a lot of things to explain. It's in my head, and I have made effort to speak it in English. But the downside of personal development is that I got too focused and I got silent, because I focus on the development, coding. So this is important. How should I work on in this broadcast? Currently, I'm motivated to study about Linux or computers or something like that, because it is needed in my work. And also I want to develop so it would be great to combine them, or I need to get certificated with the AWS, Amazon Web Service solution architect and associate. So that's it. That is another plan. can I take this exam for free? It seems like what sound? For free. I need to sign in. Okay, I think about what should I do? What should I do? It is good to review phrases, English phrases like this. Anyway, I need to improve my English skills, especially listening and speaking. And listening, it can be taken place in my broadcast. So in this broadcast I will focus on speaking, and I think I should speak about what I'm interested in, or my hobbies, or my thought, or my project, or like that. So, and the most important thing is continuing this project. I need to speak in English every day. Recently I talk with the ChatGPT. It is a good practice, but I want to speak what I'm thinking fluently. So, how to practice. I will come up with I will try to come up with ideas by tomorrow. So today I'm going to finish. Thank you for watching. Bye.